Hi kids, we'll be looking into this question which most of you will be knowing anyway how to solve. So this was the question, probably some of you would have seen it in your package. A smooth track in the form of quarter circle of radius 6 meter. Anyway, values doesn't matter to me, I just want to show you how to do the integration, especially for this force F1. F1 is always directed towards P2. Now when the particle goes from here to here, what is the work done by F1? That is what I want to do. So what I will be doing is I will be converting the question into this form. I will be visualizing there is a string and I am pulling it like this. So basically the force on this one will always be towards this particular point. That is the question. So what is the work done by this force to move it from here to here to here along the track? So let me talk about some generalized situation. So force is this way, but displacement is going to happen this way, and there is some angle between them. So work done by this force in that small moment will be given by dot product of that force and that displacement of point P. So now if I consider that angle is theta, then work done will be F into ds into cos theta, displacement of particle P into cos theta. Now I can look at this one like displacement of particle P cos theta, that is displacement's component along the string. So that particle is already on the string, so particle's displacement along the string should be same for any particle, or else distance between two particles will increase. So this thing I can say it is displacement of any particle along the string, which is same as displacement of this particle along the string, displacement of q along the string. Now the other way of saying it is, I can say work done here turned out to be exactly same as work done here. That should make sense, because whoever is doing work here, that is going as increment in kinetic energy or whatever energy in this guy, right? So work done by this force on this particle is same as work done by this force on this particle. That is the idea we got. Then that is going to be pretty easy, because when the particle is here, this length is root 2r. When the particle goes here, this length will move out by root 2r. So work done by this guy will be F into root 2r. So that will be straightforward answer. If you want to do integration, you can do integration also. If I take this angle as theta, the small displacement will be r d theta. This is 90 minus theta. Now these two lengths are same, so these two angles should be same. So this will be 45 plus theta by 2, 45 plus theta by 2, such that summation will be 180. If this is 45 plus theta by 2, this will be 45 minus theta by 2. Now if I want to take dot product, it is F into displacement is r d theta into cos of angle between them, and I have to integrate, where theta is varying from 0 to pi by 2. When I do that integration, I will be getting root 2, which is expected because we have seen in the previous question. Now taking inspiration from this, probably I will show you how to do this integration, x by root of 1 minus x square dx from 0 to 1. Now I will create a situation something like this. I will explain the situation. There are 2 point masses connected by a string, and they are free to move along this, or they are beads, you can visualize like beads, and they can move along this rod, along this frictionless rod, and can move along this frictionless rod. So when this is at this particular location where the distance between them, where the length of the string is 1, now there will be normal forces like this, and I am applying a force 1 unit here. So what force I need to apply here, such that it will be moving slowly, it is in equilibrium at every moment. So for that I will take net torque 0. So when I want to take net torque about this point, torque due to normal will be 0. Now torque due to this force should be balanced by torque due to this force. Now this length is 1, this length is x I have taken. So by Pythagoras theorem, this length will be root of 1 minus x square. So torque because of this force is x into 1. Now this length is root of 1 minus x square. So this side force should be x by root of 1 minus x square. When I multiply these two, I will be getting x. When I multiply these two, I will be getting x. So this is the scenario we created. So basically this is nothing but this force times small displacement integral. So that is work done by this force. This integral is nothing but equivalent to work done by this force. What are these limits? These limits are when x is varying from 0 to 1. The other way of saying it is, initially the situation is like this, finally the situation is like this. So this integration refers to work done by this force to convert this situation from this figure from this situation to this situation, right? Now as it is in equilibrium at every moment, work done by this force and this force should be magnitude wise same, Or if you can visualize this one like gravity, work done by this force is increment in this potential energy. You can view it as you want. Now this work done by this force is going to be this integration, which is little calculative, but work done by this force is pretty easy to calculate, because force is along this direction, this distance is 1, so our answer is going to be 1. Or you can say mg is 1, so increment in potential energy is mgh, that is 1 into 1. Work done by this force will go as increment in this potential energy, which is 1, right? Thank you.